Thank you, everyone. Hi, my name is Pawan Gupta, and I don't have my video on, so you will not see my face, but you will see what I'm going to try to show you. So let me share a my screen. So what I'm going to do today is basically showing you how to access some of the NASA data images for air quality monitoring and other applications in real time. And this is a very nice, easy tool to use. And if you have internet, I'm sure you have internet since you are listening this webinar. So just open up your browser, and if you can follow along with me, I will teach you in 5 minutes how to access these images. So let's start. I'll just open the Google and then we'll type simply worldview and NASA and then hit enter, and then the first links comes to the it says US DIS worldview NASA, and that's what the tool is. So you don't have to remember the web URL, you just type it in Google and you will find it. And if you are first time, you can take this tour, which is a nice tour which explain different parts of this tool, but I'm going to give you a tour, so I'm going to skip this. So what you see here are different parts. The major part of the screen is taken by the image, which is taken by a satellite called MODIS on board on Terra satellite, and this is image from today. And then on the left hand side, what you see here are the panels. So you see layers, events, and data. And in the layers, you can add different layers. Uh, and if you look individual layers, then you can actually, there is a symbol of eye. You can turn on and off particular layers. So for this specific visualization, I'm going to turn on a layer called SUMI NPP viewers. This is what we are going to see today. And then also, if you want to identify places name and other things, you can turn on places name, you can turn on the coastline and borders and other things. Now on the bottom you see a slider which can be used to change the date. So you can use this arrow button to go back and forth, or you can just type the year here, month, date, whatever you will type, it will come up and your visualization will produce the image for that particular date. You can also slide this bar here to go to different dates. This also works. And on the right are some of the other tools which I will show you once we start looking this demo. So let's load some of the layers. So first I want to demonstrate how the fires or the smoke from the recent campfire happened last month in California looks like from the satellite, and how you can visualize them here and how you can get some information about the local air quality. So November 7, 2018, and then I will zoom in the California region where the fires were happening, and I can see entire California now here, and this is November 7th. So if you look this true color image which shows land, ocean, there are some clouds, relatively very clear day, you won't see much happening here. So now let's start moving the dates from November 7, and I will move by one day. So this is November 8. Oh, so I see a huge smoke plume uh, just north of San Francisco, and this smoke plume is coming out from the fires here, and it is spread over large region. You can go again October 9, due to the change in the wind direction. Now the entire smoke actually is spread over much larger region. November 10, you can see much larger California, and over ocean the smoke is transported, and you will see lot more fires actually. So let's see few more parameters which will help us to identify these fires. So for that I will click on the add layer on the left side, and when I click the add layer, a pop-up window will appear, and this window will show lot of different parameters which you can display, all coming from different satellites. in near real time, and there are more than 500 different parameters related not only with the air quality but water, storm, flood, weather, fires, and many other things. So since our interest is air quality, I'll show you some of the air quality relevant parameters. So I'm going to load some of them. One is called fire and thermal anomalies. This specific product uh, actually shows the location of individual fire detected by the satellite. And you can see in this list here, there are multiple satellites or sensor which can detect these fires. I'm going to pick the one is again called SUMI NPP VIIRS, and I will click on VIIRS fires thermals anomalies daytime and nighttime. And if you see, there is a 375 meter, that's a spatial resolution of the satellite. And as soon as I click that, I close this window, I will see those two layers start appearing in my layer window on the left side. And now on the map I can see red dots start appearing on the map. If you want to see a little bit more closely these red dots, you can close the RGB layer beneath those fire layers so you can see the individual fires. Now again, I'm going to change the date so that you can see when those fires started appearing or when those fires started becoming large in size. So on November 6 and 7, you can see there are fires, but they are individual small fires. November 7, November 8, when there is a huge fire which was seen over this location over Yuba City in California. Uh, so this is another way to look to identify the fires on the map. And then if I superimpose both layers of RGB and fire detection, you can see a red dot and then the smoke coming out from these fires. Now let's look a few more days with the both layers on. You can see there is a huge fire here, and there is another fires which is actually here in the Southern California, just southeast of Fresno. And on December 10, again, entire California was covered by the smoke, and there were a few other fires started showing up on the map. Now, what we can do is we can also add few other layers. So I'm going to go again, and then I'll start. There's another parameter called Aerosol Index. It's again come from the SUNY NPP, but this is another sensors called OMS, Ozone Monitoring Instrument. And this specific sensors provide a quantity called Aerosol Index, which help us to identify aerosols or the particulate matter coming out from the specifically from the fire. They are absorbing in nature, so you can see them, and you can actually drag this layer up and down in order to see specific fields. So I put the aerosol index on the bottom so that we can see the ratio, the color scales, and we can see the names and levels of the cities to identify the location. So let's close the fire locations and also close some of these the SUMI NPP VIIRS RGB image, and then go back in time. So again, this is November 6, this is 7, this is 8. Due to some reason, the coverage. Oh, this is actually wrong layer. I have picked. Should pick the SUMI NPP aerosol index. I picked another satellite. Sorry about that. Let me bring it back here. So this is October 7, sorry, November 7. You can see the color scale is shown here. The values are very low on this specific days throughout the California, means not much absorbing aerosols. And as you start November 8, when we saw already there was a huge fire in this regions and the smoke was transporting all over the region, you can see the values are very high. The red means very high values, and that's showing large amount of the smoke. So these quantities help us to quantify actually how much smokes are there in the air. So you can see on November 10, if you turn off the visual imageries, then you can see the smoke, and then same time you can see it corresponds very well with the quantification of amount of aerosols in the atmosphere using this specific quantity called aerosol index. There are other ways to quantify that, something called aerosol optical depth. Let me add that also. So this is aerosol optical depth. I'm going to add it from aqua modis, which is about the same time as wear sensors, which is afternoon about 1:30, and I'm going to close the aerosol index so you can see. Now aerosol optical depth, one of the limitation of aerosol optical depth is that it is only available when there is no clouds, and there is the surface should also be very well behaved. So you will see some gaps in retrievals in aerosol optical depth data, but you can see again very high values on November 10 as corresponding to November 7 or 8, where the values were very low. So that's another way to quantify the aerosol index. Now, one more layer I would like to show you before we move on is called during the night time. So it's night lights. So if I type night, there are several layers comes up, and there is something called nighttime imageries. And I will pop this up here. And again, I will move the nighttime to the bottom so that I can see the levels uh, well, and I will also turn on the fire location so that I can see where the fires were. So let me zoom in a little bit over here in this part, and again I will go back to my initial date, November 7, when there were not many fires, and just watch this area in terms of the light intensity. Okay, so the white means more intense light, the darker color means low light. It's just like looking outside during the night time. So let me close the fire location so that you can see the light more visibly. November 7, November 8, and this is November 9. See this huge light intensity which was not present on November 8. This is coming from the fire. If I superimpose the fire, then you will see the entire area was burning actually uh, during that time. So this is very useful information. Now you can see many more layers. Again, just click the add layers, and you can go back and select any of the, there is a dust, fires, weather related, vegetation related options are here. Now let me just quickly show on the right hand top side. Here is this one specifically with the arrow. It's basically going to create a link to your current visual. So you want to share on social media with your friends, your colleagues or your parents or anybody. You just take this link, copy this, and then send it. It will stay live permanently. So whatever you are seeing, they will see as it is with all the selected layers and everything. You can also click on this photo and then take a snapshot of what you see, and then you can save it in a different format, JPEG, PNG, GeoTIFF for people who wants to use this in GIS tool, KMZ, which you can display on Google Earth Engine or Google Earth. And then there is a lot of which is a lot of information about this tool. There is also located on each layer, which will actually, if you click on that, will tell you about the product details, what sensor you are using, what kind of product is, and there's a link if you want to really get into details of algorithms and everything. So there's a lot of information on this page about the products which are displayed. And one more thing I would like to show quickly here is the animation feature. So suppose you want to animate and see things, how things are changing in time over this area. Let's say I want to animate this area, so I'll click this symbol next to the date, and then a pop-up window will appear, and then you can choose your starting date. So let's choose from November 7 to November 12, and then I can choose the speed, and then click on this camera button, and then it will come up with a window where I can select a small or larger regions, and then click on the create GIF. Once I click on the create GIF, depending on how large area you have chosen, how many images you have chosen, it will take some time, but it will display a it will create a GIF file which you can download, and again you can use it anywhere in your PowerPoint, social media, or for class project or anywhere. And it should come up, and you can see a GIF animation from the world view showing the smoke from different days, how it is transporting in different parts of the California. So please use this tool while you are trying to explore some of the satellite data, and this is really easy to use tool. And with that, thank you very much.